Welcome to SmartRecon. In this video, we'll walk you through how to configure the HDFC Bank API feed under the Feed Type Bank API within the Feed Configuration section of the application. Whether you're a system integrator, a business analyst, or part of our team, this video will help you understand how to use all the bank API feeds in SmartRecon application. To get started, log in to your SmartRecon application and head to the Feed Configuration module. From the main dashboard, in the Feed Type drop-down, choose Bank API. Once selected, the Feed subtype field becomes visible. From here, choose HDFC Bank to begin configuring the feed specifically for HDFC's API. As soon as you select the HDFC Bank subtype, you will see three new configuration buttons appear above. Those are URL table, query parameters, and global variable. Each of these buttons opens a modal pop-up that lets you define and manage reusable components that helps you configure the bank API connection. Let's start with global variables. Click the global variable button to open its pop-up. Here, you can define key value pairs that act as reusable parameters across your URL table in the request body or request header of the APIs. You can define keys like account number, from time, or user ID, and assign them their respective values as shown here. If a key contains multiple values, separate them with commas and set multiple values to yes. Otherwise, keep it as no for single value entries. These variables can then be used within the URL table pop-up, specifically in request headers and request body. Use this format while using it. Open curly braces, key name, curly braces close. This keeps your configuration dynamic and reusable. Next, we will to the query parameter button. Click the query parameters button to open its pop-up. This section helps you dynamically filter or fetch data from a lookup table. Start by choosing a key name. Then, select a lookup table that contains reference data. After that, input the comparing column as well as comparing values. These are used to match records in the lookup. Finally, select the column from which you want to retrieve and return the value. For example, if you want to use from date somewhere in your URL table, you might define a query parameter that fetches it dynamically based on a comparing values. Like global variables, these query keys can also be used inside the URL table module, including in the request body and request headers, using the same syntax. Next, we will move to the URL table button. When you click on the URL table, a module appears with 6 important columns: URL, media type, response, request header and request body. Basically, in URL table only you'll populate all the necessary API configuration details, everything needed to make the request and to handle the response from HDFC Bank's API. One more thing, you'll notice a button called Add Entries. Clicking on this allows you to create new API's rules. Each entry represents a distinct API interaction, and you can define its complete structure including headers, body, and endpoint. Before we proceed with filling in these fields, let's walk through the HDFC Bank API documentation to understand what each API requires, including the endpoints, request formats, headers, and responses. In this URL table, you can see there are a total of 4 API calls involved in the HDFC Bank feed configuration. These APIs need to be executed sequentially, one after the other, in the order they are defined. The first API call is an access token request, and this request is of media type URL encoded. The response received from this call will be in JSON format as shown in the highlighted part. Let's take a closer look at the request header configuration for this call. In the request header, under the key authorization, we are assigning a value. But where is that value coming from? That's determined by the parse column, which gives you 3 options: no, global variable, and URL response. If parse is set to no, it means the value is hard-coded, directly written into the header value column. This is useful for values that don't change dynamically, such as fixed credentials. If you choose global variable, the header will pull the value from a key you've defined earlier in the global variable section. In this case, you'll write the variable in this format, $keyname, as discussed earlier. And if you select URL response, The system will pick the value from the stored response of a previous API call. You'll enter the key that holds the response field you want to extract in the request header value. This is the option we'll use in subsequent API calls, where we need to send the access token that we have obtained from this first API. Now that we've covered how the request header is configured using the parse options, let's look at the request body. In the request body section, we define the key value pairs that the HDFC API documentation specifies. Here, we're using key as username, its value as SmartRecon, and parse is no. This means the value here is hard-coded. The same logic applies to other credentials like password, grant type, or client ID. If parse is set to no, SmartRecon will treat the value as a static string from the header value or body value column. But if you choose global variable, you would provide a dynamic value stored in the global variables section using the format $keyname as discussed, and similarly, selecting URL response lets you pull a value returned by a previous API call. Now let's move to the response section, where we tell SmartRecon what data to extract and store from the API response for further uses. In this first API call, the response is in JSON format, and we are interested in extracting the access token. So, we create a key named access_token, set the path to the correct JSON path, in this case, just access_token, and choose the source as body, since the token is coming from the response body. This means that SmartRecon will store the value from the JSON field access_token in memory using the key name access token. Once stored, this access token can now be reused in subsequent API calls. In the next API calls, whenever we need to pass this token in the request header, we simply use authorization value as access_token. The value will automatically be fetched from the response of the first API call. This approach ensures that your integration flow remains dynamic, chained, and fully automated, pulling response values from each API and passing them forward to the next call. Now that we've successfully configured and stored the access token, let's go through the overall process flow for the remaining 3 API calls, as outlined in the HDFC Bank API documentation. The second API we call is the History Report Generation API. It initiates the generation of a transaction report and returns a user reference number in the response. This reference number is required in the next API call. Next, the History Inquiry Report API is called. In this call, we send the user reference number as part of the request payload. This API returns a status in the response. SmartRecon automatically rehits this API in the background until it receives a success status. You don't need to do anything manually here. This is fully handled by the backend logic. Once the status becomes success, SmartRecon moves to the final API, the History Download Report API. This API returns the actual transaction data, but unlike other banks that return it in JSON format, HDFC Bank sends it as a base64 encoded file string, essentially a file in byte format. Because of this format, SmartRecon handles column extraction differently for HDFC. At the end of this video, we'll also show how this differs from other banks like Axis Bank or Oracle NetSuite, where transaction data is returned in simple JSON and column values can be extracted directly using JSON paths. In the next step, we'll walk you through the complete configuration of these 3 API calls inside the URL table, including how we set up request headers, body, response parsing, and how values are passed from one call to the next. Now, let's move back into the URL table and begin configuring the second API call, the History Report Generation API. Here, you can see the URL we're using is for report generation, as per the HDFC documentation. The media type for this API call is set to application/JSON. This means that both the request header and request body will be in JSON format, and the response type will also be JSON. Now let's configure the request header. As mentioned in the documentation, we need to send 2 headers, authorization and username. For authorization, we will send the access token retrieved from the first API call. key, authorization, its value, access underscore token and parse is, URL response. This tells SmartRecon to use the value stored from the access token API, where we earlier saved the token under the key access underscore token. The second header is, key is username, its value is SmartRecon and parse is no. This is a hard-coded value, directly entered in the configuration. Let's move on to the request body. According to the HDFC API documentation, the structure of the request body is predefined. We'll copy this structure and paste it directly into the request body field. Within this request body, you'll notice dynamic placeholders like r_reported. This is fetched from the global variable section start_date and end_date. These values come from the query parameters. This allows the request to be fully dynamic based on configuration inputs. Now let's define what we want to extract from the API response. In this case, the API returns a user reference number in the response body. So in the response section, key, ref_number, path, ref_number and source, body. This means that the value inside the field ref_number in the JSON response body will be stored using the key ref_number. We'll then reuse this value in the next API. With this, we've fully configured the second API call. We've chained the access token from the first call, pulled in global and query values into the payload, and saved the user reference number for downstream use. Now let's move on to the third API call in the HDFC process, the History Inquiry Report API. This API checks whether the requested transaction report has been fully generated or not. The media type for this API is once again set to application/JSON, and the response type is also JSON, just like the previous call. Let's begin with the request headers. These are exactly the same as in the second API call. Key is authorization, its value is access_token and parse is URL response. Now another header key is username, its value is SmartRecon and parse is no. We're using the access token retrieved from the first API and a hard-coded username, just as before. Now, let's move to the request body. The request body is in JSON format and follows the structure provided in the HDFC documentation. Here, all key values in the request body are being fetched dynamically from global variables. For example, fields like $ref_number, the user reference number returned from the previous API, I passed using the same $key_name format. All of these values are resolved from either global variables or previous API responses, as configured. Now let's move on to the response. The goal of this API call is to return the status code of the report generation request. So here, in the response section, key is status, its path is inquire rpt details .cod status, or the exact path based on your documentation, and its source is body. This means SmartRecon will read the status field from the response body and store it under the key status. This status is internally checked by SmartRecon, and the backend will automatically retry this API call until the status becomes success. You don't have to manually recheck or configure a loop. This retry mechanism is built into the platform. Once a success status is received, SmartRecon will automatically move on to the fourth and final API call, which we'll configure next. Now, let's move to the fourth and final API call in the HDFC Bank Feed integration, the Download Report API. You can see in this configuration that the media type is set to application/JSON, and the response type is again JSON. Just like before, all the request headers and request body elements used here are defined in the HDFC documentation. In the request header, you can see that all the headers are same as the previous two API calls. The request body is in JSON format, where we provide the required download report DTO as specified in the documentation. This body includes ref_number, the user reference number returned by the second API call, additional fields coming from global variables and URL response keys. We simply paste the provided JSON structure into the body and dynamically link the values using $keyname format. In this fourth and final API call, we are not storing any response. Why? There are no further API calls that depend on this response. Also, there is no case of pagination here. And HDFC's download API response is a base64 encoded byte string, which is internally handled by SmartRecon for column extraction, so we don't need to pass or store values here. But that's not the case with every bank. In platforms like Oracle NetSuite or Axis Bank, you'll need to handle pagination in the response section of the final transaction fetching API. Let's break it down. In NetSuite, the API response contains a key called hasMore. If hasMore is true, it means more pages exist. In that case, you must also store the value of the offset key, because this offset will be needed to fetch the next page of results. You can clearly understand this by checking the NetSuite API documentation, or better, try these calls in Postman. In Axis Bank, it's a bit different. Here, the API response contains an X key. If next is null, you're done, there are no more pages. But if it's not null, it means another page exists, and SmartRecon will automatically call the API again to fetch the next page. So remember, when you're configuring feeds like NetSuite or Axis, make sure to handle pagination in the response tab of your final API call. SmartRecon supports this seamlessly. It detects pagination flags like hasMore or next, stores values like offset, and triggers the next API call automatically, behind the scenes. No manual looping required, it's all part of the smart automation. This was all about the URL table configuration. Now, let's go back to the main feed configuration page. Scroll down to the bottom. Here, you'll find the retry API calls setting. You can set a number between 0 and 4. This means that if an API fails, SmartRecon will automatically retry it up to the number of times you specify. For example, if you set it to 4, it will retry the failed API 4 times before stopping. This helps improve reliability in case of intermittent issues. Next, we move to the Feed Columns tab. Here, we define the column name and its position, based on the order of data inside the base64 byte string returned by HDFC. You must enter the columns in the same order as they appear in the decoded byte string. You can refer to the HDFC API documentation for the correct sequence or try using Postman. But when configuring APIs like Axis Bank or Oracle NetSuite, the response is in JSON format. So instead of position, you'll configure column name, any name of your choice, and its path. Here, path refers to the JSON path of the field you want to extract from the response. This is the main difference between HDFC and other bank APIs. HDFC gets file-based byte response, uses position. And Axis, NetSuite gets JSON response, uses path. SmartRecon supports both styles of parsing, depending on the API. And that wraps up the complete configuration flow for the HDFC Bank feed in SmartRecon. From defining global variables, to configuring all 4 API calls, handling retries, and mapping columns, everything is designed to be flexible and powerful. Thank you for watching.